So, what did you eat today? Rice or chapati? Maybe with pulses or vegetables? And what are you wearing? Cotton, silk or synthetic? Anyway, you must be wondering why I am asking. Whatever you have eaten today and whatever you are wearing, all that is due to carbon and its compounds. There are so many compounds that are made of carbon that we can say that one claim is almost 10 million compounds are made of carbon, or at least 3 million compounds we know, and we know their formulae. So, everything, whether it is protein or fat or carbohydrate, all are made of carbon, and also simple compounds like carbon monoxide or carbon dioxide. So, there must be lot of carbon available? Not really. On Earth's crust, there is only 0.02%. Earth's crust. And in air, of course, you must be knowing 0.03%. In an ionic compound, when the bond is electrovalent, electrons are either lost or they are gained. When electrons are lost, it becomes a negatively charged particle, an anion, and when the electrons are lost, then it becomes positively charged particle, a cation. Now, let us take the case of carbon. Carbon has atomic number 6, which means there are 6 protons and 6 electrons. Now, let us see what is its configuration. Its configuration is that there are 2 electrons in K shell, and in the L there are 4. Now, as you know, every atom is all the time striving to attain a noble gas configuration, which means that there will be 8 or 2 electrons in the outermost orbit. So, to be able to achieve that situation, there can be 2 ways. First way is that 4 electrons are gained. So, if 4 electrons will be gained, then electrons will become 10 while proton will be 6. How will 6 positive charge manage 10? It cannot. And if it does, then the carbon will become C minus 4, that is anion. Okay. What is the second situation? 4 electrons are lost. If 4 electrons are lost, then the protons will be 6 and electrons will be 2. That means to be able to allow electrons to move away from the effect of nucleus, the 6 protons, lot of energy will be required. And if it happens, then it will become C positive 4 or a cation. But both these situations are not possible. So, a quick review of propane and its derivatives. When there is a single bond, then suffix is ane. Formula is C3H8. Now, when it is a halogen derivative, chloro or bromo, there will be a prefix, chloro or bromo. So, it will be chloropropane or bromopropane. If it is an alcohol, then we will not use a prefix, but we will use a suffix, and the suffix will be OL. So, one E will be removed, the last E will be removed and OL will be added. So, it will be propanol. Then if it is an aldehyde, then again suffix Al, so it will be propanol. If it is a ketone, we will add ONE, but we will not pronounce it like one. So, it will be propanone. If it is carboxylic acid, then we will add OIC acid. So, it will be propanoic acid, propanoic acid. If there is a double bond, then the suffix will be ene. so it will become propene. If it is triple bond, then YNE, so it will be propyne. So like this the names will change. It can be ethyne, ethene, butene, butane and so on. So when carbon combine with hydrogen, then the compounds are called hydrocarbons. So there are some general chemical properties of hydrocarbons. The first property is combustion. Carbon itself also and all compounds of carbon also can burn. That is why they are also used as fuel. Coke, coal is nothing but carbon and it is used as a fuel. So what methane, another hydrocarbon that is also used as a fuel. So let us take the example of carbon. Carbon plus oxygen will form carbon dioxide. All non-metals can burn to form their respective oxides. So carbon also does the same. Then let us take the case of methane. This will form carbon dioxide and water. When methyl alcohol also burns, this also forms carbon dioxide and water. And in all these three reactions, lot of heat is generated. So these are exothermic. Now because heat and not only heat, even light is generated, these are used as fuel. Coal or coke is used as fuel. Then methane is a part of CNG and biogas. Both are used as fuel. And methyl alcohol, which is commonly called spirit and is used in spirit lamp, even that is used for burning. Now the question arises that why a flame is produced when something is burnt. These days it is not very common, but in villages still for cooking purposes either wood or coal is used. Now when wood or coal is used, initially they form a flame, but later on they don't. They only glow, lot of heat is produced, but there is no flame. Why so? You burn candle, there is a flame. You burn a stove, you burn a gas burner, there is a flame. Why there is no flame in wood or coal? Because a flame is formed only when vapors are burnt. Then why they are burnt initially? There is a flame in wood and coal, because when the volatile substances which are present in wood and coal, they vaporize and they burn, they form a flame. But later on no flame is formed. But in the case of wax also, the wax vapors burn to form a flame. So maximum heat is produced when the fuel is a gas, like for example LPG or biogas. But in the case of liquids, the heat generated is less than gaseous fuels like kerosene oil. Similarly, in the case of solid, it is the least, like coal and wood. So that is why these days we prefer gaseous fuels like LPG, because they are more heat efficient. On Diwali, we burn diyas, and what is the fuel used? Mustard oil. And if we cover the main diya, which has 4 twigs in it, with a iron blade, then lot of carbon black gets collected in the form of soot, which is used as kajal, and it is called carbon black. Even sometimes when our gas is not functioning properly, the vessels turn black. Why this happens? This is due to unburnt carbon particles. It can happen either due to insufficient supply of oxygen, or it can happen because of the kind of compound it is there. The saturated compounds produce a luminescent flame. The saturated compounds form a luminescent flame, which is blue in color, like methane. But the unsaturated compounds, they produce a yellow flame. and the result is that it produces unburnt carbon, and that is why it turns black. But not necessarily, it can also be due to insufficient supply of oxygen. If you have seen your gas burner carefully, there are small holes for oxygen. Sometimes due to boiling of a dal or some other kind of cooking, these holes get blocked and then the flame is not blue, and the result is that vessels start turning black. Another reason is using vegetable oil, like the example of Diwali diya. So, in that case also, because the compound is unsaturated, because vegetable oil has unsaturated fats, there will be production of soot. But in the case of saturated fats, like a diya of pure ghee in your temple, no soot is produced, and that is why we generally in India prefer a diya of pure ghee, because it is a saturated fat and it will form a clear flame. Actually, what happens chemically when combustion takes place? There is addition of oxygen. And what is addition of oxygen? Oxidation. So, what we find is that carbon and carbon compounds, they can easily be oxidized. Let us see how. So, next property is oxidation. You know, there are some compounds which can easily give oxygen to another compound. They are called oxidizing agents. For example, alkaline KMNO4, because KMNO4 can easily release oxygen atoms, or acidic potassium dichromate K2Cr2O7. When methyl alcohol is oxidized, then one thing is that it can burn. Another type of reaction is that it changes into an acid. For example, ethyl alcohol plus oxygen, either alkaline KMNO4 or acidic potassium dichromate, and what we get is ethanoic acid. So, what has happened? This compound potassium permanganate or potassium dichromate has provided oxygen which has been added, and what we get is an acid. In the case of unsaturated hydrocarbons, some atoms can be added, and these are called addition reactions. Like I told you that just like you, these unsaturated compounds are always hungry for more electrons, because they are after all sharing 2 electrons. So, easily hydrogen atom can be added to them. For example, R is for the functional group, this takes place in the presence of a catalyst like palladium or nickel. And what is this called? Hydrogenation. Like I told you, unsaturated fats can be hydrogenated and converted into saturated fats, but that is very dangerous, because not only nickel is harmful, also the saturated fats get deposited in the blood vessels as cholesterol. As a result, the heart has to pump more, it has to work harder, and that can lead to heart problems. So, now you understand why it is healthier to take vegetable oil. Now, is it only hydrogen that can be added? No, even the halogen atoms can be added. but not under normal conditions, only when it is exposed to sunlight. Now, let us see how that happens. For example, if you take ethene and chlorine is added to it, what you will get is now one of your friends, a very good friend, leaves the school. What do? You find another friend. So, similarly, the carbon compounds, what they can also do is that not only they can add, like I just showed you in addition reactions, but sometimes they substitute, like hydrogen is replaced by halogens. These reactions are called substitution reactions. For halogens, the requirement is sunlight. For example, when methane combines with chlorine in the presence of sunlight, what we get is chloromethane, and this can go on like this. Till all the 4 hydrogen atoms are replaced by 4 chlorine atoms, and then it is called carbon tetrachloride. Okay, now what about alcohols? Alcohol is a dreaded word. Alcoholic drinks cause lot of problems, social, physical as well as mental. But before going into that detail, first let us understand what is alcohol. Let us take case of ethyl alcohol, which is also called ethanol. The chemical formula for ethanol is CH3CH2OH. Now, you have seen that it is in the liquid form. So, one property is liquid at room temperature. Second, it is soluble in water. It is also combustible. Now, this is a bane of our society, because this is becoming more and more prevalent that alcoholic drinks are served in parties and even individually people take it. Now, when ethanol is taken in a diluted form, even in small quantity, it affects a person. What is the result? There is loss of time judgment, or in other words, we say that increase in reaction time. Because it reaches the central nervous system and makes it dull. As a result, the person will react all right, but it will take much longer. That is why drinking and driving should never be mixed, because for driving you need lot of precision. Similarly, for flying also. When acids and water react with metals, they release hydrogen. Even alcohol, when it is added onto metals, it forms hydrogen. Let us see how. CH3, CH2OH plus Na. Now, sodium being a more reactive metal, actually it is one of the most highly reactive metal. It is able to replace hydrogen. So, what we get is CH3, CH2ONa plus H2. So, hydrogen is replaced by sodium, and this is called ethoxide. Now, what happened when sodium combined with, say, HCl? We got NaCl plus H2. Even with water, hydrogen is released. So, same is the case with alcohol, that sodium can form ethoxide. Alcohol can be easily dehydrated. See, otherwise also when we consume alcohol, there is dehydration in our body. So, that is another problem. That is why even the kidneys get affected by the effect of alcohol. Now, how this happens? CH3, CH2, OH, in the presence of sulfuric acid, it gives C2H4 plus water. Are you fond of Chinese food? A very important ingredient of Chinese food is vinegar. Even for making pickles, vinegar is used. In winters, when we pickle vegetables like carrot, turnip or cauliflower, vinegar is used. Even to preserve things like onion or green chili, vinegar is used. What is this vinegar? Vinegar is actually 5 to 8% solution of acetic acid. Now, this acetic acid has a low melting point, about 290 K. So, in winters it gets solidified, and that is why it is called glacial acetic acid. If you combine acetic acid with alcohol, you will get a very pleasant smell, a fruity smell. This is because of esterification. CH3 CH2OH plus CH3 CH2 COOH, and what we get is so that is why esters are used as flavoring agents or in the perfumes. As it is an acid, it can combine with the base to form salt and water. For example, NaOH plus CH3COOH gives us CH3COONA plus water. This is a neutralization reaction. This is also used for soap formation. In soap, what we use is oil or fat, which contains fatty acid. So, when sodium hydroxide is added to it, we get a sodium salt of the fat, and then that is converted into soap. Second is, again, just like mineral acids, it can also combine with carbonates and hydrogen carbonates. The ethanoic acid also reacts with carbonates and hydrogen carbonates, and just like mineral acids, they produce salt, carbon dioxide and water. So, Na2CO3 plus CH3COOH, CH3COONA plus carbon dioxide plus water. In the case of hydrogen carbonates, the products are same, so no balancing is required. The third is action with alcohol. If in a test tube you take some ethanoic acid and ethyl alcohol and indirectly heat it in a water bath, you are in for a surprise, and that too a pleasant one, because it produces ester which has a very pleasant smell, and that is why it is used in perfumes. How this happens? CH3 CH2OH ethyl alcohol plus CH3 COOH. So, what will it give us? It will give us ester. plus water. Now, because ester has a pleasant smell, it is used as flavoring agent in cooking and also for making perfumes. And this process is called esterification. For making soap also we use an acid, but that is a fatty acid which is a part of fat or oil. So, when this fatty acid combines with sodium hydroxide, we get a sodium salt of fatty acid. It is this sodium salt of fatty acid which forms soap. Now, soap is a very interesting molecule. Why? Because it has two ends like this. This end is ionic or the sodium end, while this end is hydrocarbon end. This is hydrophobic and this is hydrophilic. What does that mean? This means it is friendly with water, while phobia is fear. This end is scared of water. So, what will happen? Now, when we use soap for cleaning our clothes, what happens is that this soap molecule, its one end is away from on the surface of water. So, the tail end forms a circle like this. This is called micelle, and the dirt is captured in the center, or the grease or the oil, just like Chakravyuh. Remember how Abhimanyu got trapped in a Chakravyuh? That is how the dirt gets trapped in the soap molecules. Now, the tail end will penetrate water and so it will react with the grease, and now this dirt remains in the form of colloid in a solution, because ions of same charge repel each other. It does not precipitate. So, very good, because when you wash clothes, the dirt never precipitates. In fact, it remains suspended in water. So, when we rinse clothes in water, the soap or the soapy water and the dirt remains in water and the clean clothes come out. The problem arises when water is hard. If we take two test tubes, in one we take hard water, in one we take rain water, which is very soft water. So, what will happen? You put a little of soap in both. Where will more foam form? When the water is soft or the rain water. Now, what is hard water? Water which has calcium and magnesium salts is the hard water, and so soap is not able to form the foam. So, what is the solution? The solution is detergents like washing powders or the ones which are used in shampoo. Or there is a traditional method that if we add sodium carbonate, then sodium will be able to replace calcium and magnesium salts and water will become soft. So, sodium carbonate is also used to remove permanent hardness, or in the case of detergent, it is able to make a bond, and as a result the clothes can be washed easily. Fossil fuels, they are coal and petroleum. When plants get buried in the earth's crust, then due to heat and pressure it changes into coal. And what about petroleum? When the animals get buried and bacteria act on it and they settle down in the sea beds, then they convert into oil and gas, and then we are able to extract petroleum. Now, just imagine one day when you come to school, you realize you haven't brought your tiffin. So, you are hungry, what will you do? Probably you will ask your best friend. Now, the best friend is in a dilemma. If he gives you the tiffin, then he goes hungry. If he does not, then the friendship is broken, or he will be labeled as selfish. So, what do? You share your tiffin. That is exactly what carbon does. Carbon shares electrons. The 4 electrons deficiency is fulfilled by sharing. This kind of bond is called covalent bond. It is not just the carbon which shows covalent bonding. There are many other elements which also show this kind of bonding. Let us take the case of hydrogen. The atomic number of hydrogen is 1. So, in the K shell there is only 1 electron. Now, it wants to be like helium, because helium is the noble gas, nearest noble gas, and that has only 2 electrons. So, which means it has to gain 1, but who will give that? So, what happens is that there is another hydrogen atom and both share their electrons. So, what becomes of it is a hydrogen molecule. So, for the formation of hydrogen molecule there is a covalent bond between hydrogen atoms. Let us take another case, oxygen. Atomic number is 8. So, first shell will have 2, second will have 6. Now, this also requires 2 more electrons. Once again, sharing with second atom. That means now the sharing is between 2 electrons. So, whenever there is sharing of 1 electron, it is called single bond, and the compound is called, or the molecule is called saturated, that means fully satisfied. And when there is double bond or there are 2 electrons shared, then it is called double bond, and this is called a unsaturated molecule. Now, not only hydrogen and oxygen, there are others also, like nitrogen. The atomic number of nitrogen is 7. So, the first one will have 2 and then 5. Now, it needs 3 electrons. So, another nitrogen atom, so 2 are free, but 3 are being shared. So, when 3 electrons are shared, it is called triple bond. This is also unsaturated, and the resultant is nitrogen molecule. The properties of a compound depends upon what kind of bonding it makes. For example, in the case of ionic compounds, we saw that the bond was electrovalent because there was either loss or gain of electrons. Now, in ionic compounds, the electrostatic force of attraction is very high, and what is the result? The result is that ionic compounds have high melting point and boiling point. On the other hand, the compounds showing covalent bond, they have weak electrostatic force of attraction. So, their boiling points and melting points are low. For example, many of the carbon compounds like carbon dioxide, methane, ethane, they are all gases. So, we can say the first point is weak electrostatic force of attraction. And what is the result of this? Low melting point and boiling point. Secondly, because there is sharing of electrons, there is no loss or gain of electrons, there is not formation of charged particles. There are no anions or cations. So, what is the result? It is a bad conductor of electricity. In the case of ionic compounds, in their molten state or solution form, they are good conductors of electricity. In the case of carbon, there is one more advantage, and that advantage is that the bond is short. Why it is short? Because the distance between the nucleus and the outermost shell is less. So, the electrons are always attracted towards the nucleus. Why is it less? Because there are only 6 electrons which get distributed in 2 shells, K and L, 2 in K and 4 in L. So, the bond is short. Now, imagine if an element has high atomic number, the number of shells will be more. So, the effect of nucleus will be less. Now, let us take the case of water. In case of water, there is oxygen having 6 electrons, and then one electron is shared with one hydrogen and second one is shared with second hydrogen. Now, this time instead of dot I have used, instead of cross I have used dot. Why? Because hydrogen is another element. So, what we get is H2O. So, everybody is satisfied? That means there is a single bond. Similarly, in the case of ammonia, there is nitrogen and there is a need of 3 electrons. So, one hydrogen, second hydrogen, third hydrogen. So, 1, 2, 3, 4, 5, 6, 7 and 8. So, it is like this. NH3. The carbons also attach with hydrogen, and the simplest form of hydrocarbon is called methane. Its formula is CH4. That means one carbon atom will be attached with 4 hydrogen atoms. This is carbon, this is one hydrogen atom, this is second hydrogen atom, third and the fourth one. So, basically what we get is CH4, 4 electrons of carbon and 1 each of the 4 hydrogen, total is 8, and each hydrogen is also getting 2. So, here also there is a single bond and a saturated compound. So, all these compounds are showing covalent bond. Another interesting thing about these molecules is within the molecule the bond is very strong, lot of force of attraction. But intramolecular, the force of attraction between different molecules is weak, and that is why most of these are in the form of gases. They are found in the gaseous state. Let me tell you the story of 2 brothers. Now, they were the progeny of same parents, but one was very pampered while the other had to face lot of hardships. So, what happened? Due to all the hardships, that brother became very strong-willed and very determined and became a great achiever. Same is the story of carbon. When carbon under very high temperature and pressure inside the earth's crust changed into diamond, and diamonds are forever. Very valuable, they have shining luster, they sparkle in light and they reflect light, they even refract light. So, they are really considered very valuable by kings, queens and even common people. On the contrary, there is another form of carbon, and that is grey in color. Not that it is not useful, it has some other qualities. Like you can say one brother was good in academics, other was good in the sports. So, you see in this case what happened? The other one had a smooth and slippery surface, and it was not very hard and rigid like diamond, and it was a good conductor of electricity. So, we could use it in the batteries. And what is that second brother? Graphite. So, what we find is that carbon is found in two physical forms, diamond and graphite. Diamond is hard and rigid, while graphite is smooth and slippery. High density, that is why it is hard and rigid. Low density. Sparkles, doesn't. Not a good conductor of electricity. Most of the non-metals are not good conductors of electricity. While this is good conductor. Now, why this? Why two physical forms? Are they really different from each other? No, both are carbon and both have same chemical properties. You burn them, you will get carbon dioxide. So, we have to understand what is this phenomenon and why this difference. This phenomenon or these two are called allotropes, and the phenomenon is called allotropism. All right. We understand that diamond and graphite are allotropes, but why? The reason is their structure is different. In the case of diamond, one carbon atom is attached to 4 carbon atoms, which means if it is in the form of layers, 3 carbons are attached on the surface and 1 down below. So, the result is there is a 3-dimensional structure, and that is why it is hard and rigid. This is in the case of diamond. But in the case of graphite, the 1 carbon atom is attached to 3. They are kind of hexagonal arrays stacked together, one above the other like this, but they are not connected in the layers. So, they are just hexagonal, means when they have 6 branches. So, they are hexagonal arrays placed one above the other, but just the layers are not interconnected. And now you can well understand why they are smooth and slippery, because this next connection is not there. But then the question arises, how are the 4 valencies or the 4 electrons satisfied? How is the carbon satisfied? 3 carbons will give 3, 1 has a double bond. So, with 1 carbon there is sharing of 2 electrons, and that is how all the carbon atoms get satisfied in the case of graphite also. And this is the reason for their properties, difference in their properties. Diamond is hard and rigid, graphite is soft, smooth, slippery, and diamond is a non-conductor, while graphite is a good conductor of electricity. Recently, another form of carbon has also been found, and this is called C60 fullerenes. Don't miss this E's. There are 3 E's, E, R, E, N and E, S. Fullerene is the word. Now, in this case, the substance is like a football, as if the carbon atoms are arranged on the surface like a football. Now, why the name fullerenes? Because this structure resembles a dome called geodisc. Disc, you go for disc, discos you go, so remember from there, geo means earth. So, this geodisc dome, who designed it? There was an architect called Buckminster Fuller. So, the word fullerenes is from Fuller. Now, remember it's minster, not minister. So, I is not after N. There is a tendency to get confused about such spellings. So, remember it is Buckminster Fuller, and on his name this new form of carbon was put. There are some students who are very good in academics, getting full marks in all the subjects. There are still others who are good in sports, and still others are good speakers or are very good in histrionics. But there are some students who are good in everything. They are all rounders. Such students, such people are called versatile. You can say they are kind of multitasking people. They can do many things with equal competence. Carbon is like your all-rounder best student. Now, why is it so versatile? Let us understand. First thing is that it is carbon is the only element that can combine with another carbon and thus form very long chains. No other element can do that. Yes, silicon can. Silicon can also combine with hydrogen and form about a chain of 7 to 8 atoms. But this chain is very reactive, unstable, while carbon chains are stable. Isn't it something like our own country? In our country also, we are all bound together. We may be otherwise different, but we are together, always together. This property of having a strong bond is called catenation. Why I gave the example of your own country, your nation? Because this property has nation in it, catenation. So, the carbon has the property of catenation, because of which the compounds are in the form of chains or can be branched or can be in the form of rings. We will get into the details of these forms. So, this is one property of catenation that makes carbon versatile. Secondly, it can form single, double or triple bond. So, whatever the requirement, if one electron is not available, it will make double bond. If two are not available, if one is not available, it will form single bond. If two are needed, double, and if three are needed, triple. So, whatever the situation, accordingly it adapts itself. Just like some people, they can make friends with anybody, with lots of people they can make friends. So, they are very popular even among the students or among the teachers or anybody for that matter. There are some people who can create a bond with any and every one. So, they make friends very easily. Similar is the case of carbon, it can form single, double or triple bond. Another thing is that it cannot, not only it forms a bond with carbon, it can also form bonds with others. Once again, just like Indians, not only they have a bond with each other, whichever country they go, they form bonds. So, it can form bond with hydrogen, oxygen, nitrogen, sulfur or halogens also. And as a result, you can understand why such a huge variety of compounds. Carbon can combine with carbon, carbon can combine with hydrogen, with oxygen, nitrogen, sulfur, halogens like chlorine and bromine. So, obviously, the options will be so many, and the result is that not only there is so much of variation, there is variation in the properties also. Again, like India, whosoever came here, we imbibed them, whether they were the invaders or not. As a result, our heritage is so rich. So, here also these outside atoms come and they bring in their own properties, specific properties, like protein has nitrogen or sulfur, along with of course carbon, hydrogen and oxygen, while hydrogen and oxygen along with carbon is present in the fats or the carbohydrates. So, like this we find that carbon is a versatile element. The carbon compounds, as I just now explained, have the capacity to share one electron with either carbon or hydrogen or any other element. So, when only one electron is shared, then what we get is single bond forming a saturated compound. This is when only one electron is shared. So, when 2 electrons or 3 electrons are shared, then we get double or triple bond. And both these are unsaturated. For example, the vegetable oils have unsaturated compounds, while the animal fats have saturated compounds. You must have heard doctors or other in ads always saying that we must take vegetable oil because it is good for heart. Why is animal fat bad for heart? Because you see, the saturated fats, they can settle down in the form of cholesterol in the blood vessels, and when blood vessels will have cholesterol inside them, naturally the passage will get clogged, and when there is clogged passage, heart will have to pump extra, it will have to work harder because the passages are not clean, and as a result there can be heart problem. So, they say that you require bypass surgery because the arteries are blocked. That is all because of this. And so, if we take unsaturated fats or the vegetable oils, then this problem will not be there. But these unsaturated fats, because they are a little dissatisfied, like your friend who was still a little hungry when you shared your lunch and you were also a little hungry, then there is always need for a little more tiffin, some more tiffin from another friend or running to canteen. So, the unsaturated compounds are always also looking for another element which could be carbon or which could be any other element like hydrogen and oxygen, which will give it electrons. Mostly it is hydrogen. This process is called hydrogenation. The examples of saturated compound are, one was methane, that is CH4, then ethane, C2H6, like this. So, 1 electron is shared with carbon, 3 with hydrogens. Then there is propane. Three with first carbon, 3 with last carbon and 2 in the center. Why? Because it is getting 1 electron from this carbon and 1 from this. So, it needs only 2 hydrogen. So, like this, these kind of compounds are called saturated compounds because they have a single bond. There are other kind of compounds like ethene. Formula is C2H4. So, here first step is carbon and carbon has formed a bond. Second step is the 2 carbon atoms are getting attached. So, how many electrons are being shared? 3. What about the fourth one? 1 more electron is required, otherwise it will be only 7. So, there is in step 3 there is a double bond between carbon. This is called ethene. There can also be propene. Which is C3H6. So, here there will be again double bond. Such compounds are called alkenes. So, there was alkane, there was and now there is alkene. Alkenes are methane, ethane, etc. Alkenes are ethenes. There can be one more, and that is ethyene. It is also called acetylene. So, first step will be, second step will be, and third will be a triple bond. So, whenever there is single bond, it is a saturated compound, and whenever there is a double or triple bond, it is an unsaturated compound. Now, let us take the case of some trees. They just keep on growing tall, they do not branch, like dates. Even the climbing a date tree or a palm tree is very difficult. You must have seen there is a special technique how they keep on jumping like monkeys and keep climbing up. But there are some trees which start branching like this. Similarly, in the case of carbon compounds also, some form long chains like this. And it can be very, very long also, hundreds of atoms. But in some cases, there is branching. Let us take the case of butane, C4H10. Right? So, 3 atoms here, 3 atoms of hydrogen in the last one. 2 in the center. Why? Because they are also getting from 2 electrons from 2 carbon atoms. So, total is C4H10, but there is another possibility. After 2 carbon atom, this carbon atom may be attached to 2 carbon atoms like this. Then what will happen? 3 hydrogen atoms with first carbon, 1 with second. Why only 1? Because it is getting 3 electrons from 3 carbon atoms. So, only 1 is required. This carbon atom will be attached to 3 hydrogens and this will also be attached to 3 hydrogens. So, 3 plus 3 6, 7 and 3 10. Now, what is this structure? This is branched. Now, you see, interestingly enough, say there are 10 boys and girls standing in one line, they can just hold their hands. So, what will that resemble? That will resemble a chain like this. This is a chain. Or maybe the last student is holding hands of 2 students, that will be branched. But what if they form a ring? The first child and the last again hold hands together. So, that will be the formation of a ring, as in the case of cyclohexane C6H12. So, there are 6 carbon atoms which are arranged in a hexagonal fashion, and each carbon atom is attached to 2 hydrogen atoms. Single bond is there because this is fully satisfied. So, what we get is C6H12. Now, in another case, that is benzene, the formula is C6H6. In this case, what happens? There is only 1 hydrogen atom attached. So, how will be electrons satisfied? How will be the atom satisfied? There will be alternate double bonding. Carbon is like Indians. Just as we don't differentiate between people belonging to different states, so is the case of carbon. It likes to make as many friends as it can. So, not only it forms a bond with carbon, it also forms bond with hydrogen, oxygen, nitrogen, sulfur, chlorine or bromine, because they are all monovalent atoms and they can also give their own electrons, or they can also share the electrons, and so you can, that is the reason that there is such a huge variety of carbon compounds. Now, as these atoms are different, they are called heteroatoms. Heteroatoms bring their own properties and change the property of the compound. For example, chloromethane will have slightly different properties than methane because chlorine has come in it. Similarly, in the proteins there is also nitrogen and sulfur. Basically, it is made out of amino acids, so its properties will be different. So, these heteroatoms change the properties. Sometimes these atoms like oxygen and hydrogen are present in a specific way, and that is called the functional group. Like members of a family, brothers and sisters, the siblings, they may have some differences, but still there are some common features. So, in this case also what we find is that there are functional groups, like for example OH is for alcohol, CHO is for aldehyde, C double bond O is for ketone, C one bond with hydroxyl ion and one with oxygen, and this forms carboxylic acid. So, all those compounds which have same functional group, their properties will also be same. The number of carbon and hydrogen atoms changes. So, the mass also changes, but their only physical properties change, chemical properties remain same. For example, the properties of methyl alcohol and ethyl alcohol or propyl alcohol will be same, but their physical properties will be different. The functional group will be chloro or bromo, and in the formula we will have Cl or Br. For example, chloromethane is CH3Cl. If the heteroatom is oxygen, then if there is OH with a single bond, it is alcohol. If there is CHO, now here you can see there is a single bond with hydrogen, but with oxygen there is a double bond, then it is a aldehyde. Now, the example of alcohol we can take as CH3OH, the methanol or the methyl alcohol. Example of aldehyde can be CH3CHO. Then there is a ketone, C double bond O. Then there is carboxylic acid, which has a carbon which has a double bond with O and a single bond with hydroxyl. So, it will be like CH3COOH, methanoic acid. Aldehydes and ketones are isomers. They have same molecular formula, but their structure is different. When the compounds have same functional group, like say alcohol functional group, that is OH or COOH or CHO, then in that case their functional group is same, but the number of carbon and hydrogen atom changes. Now, for example, if we take the case of alcohol, there is methyl alcohol CH3OH, then there is ethyl alcohol C2H5OH, then there is C3H7OH. This is methyl alcohol, ethyl alcohol and propyl alcohol. This functional group is same, but the number of carbon atoms are increasing, one every time. And how many hydrogen atoms are increasing? 2. So, that means carbon and hydrogen atoms are changing, they are increasing, and if they are increasing, obviously the atomic mass is also changing. For example, the atomic mass of carbon is 12 mu and that of hydrogen is 1 mu. Now, the difference between the two compounds is CH2. So, that means total difference is of 14 mu. So, as we move on, the molecular weight keeps on increasing, and as a result the melting point and the boiling point also keeps on increasing. That means the physical properties keep on changing, but because the functional group is same, the chemical properties are same. So, every time the molecular mass is increased by 14 mu, so the properties also change. The melting point and boiling point keeps on becoming higher and higher, it is in ascending order, but the chemical properties are same. Why? The functional group is same. It is just like the siblings of a family may develop some differences in them, but yet the basic value system of a family will remain same. So, this is like belonging to same family. This is called homologous series. another example, going back to our simple compounds. One type of compounds are, I told you, alkanes. In case of alkanes, there is methane, CH4, ethane, C2H6, propane, every time the difference is of CH2, right. So, what will be the general formula for this? The general formula is CnH2n plus 2, where n is number of atom. So, if n is equal to 1, then it will be C1 H2 into 1 plus 2 is equal to CH4. So, we can say the general formula for alkanes is CnH2n plus 2. Now, let us take another case of alkenes. Ethene is C2H4, propene is C3H6, butene is C4H8. So, what is the general formula? CnH2n. Let us take this first case, C2, so this will be 2 into 2, so C2H4. If carbon atoms are 3, C3H, 2 into 3, so it is C3H6. Third kind of compounds in which there is triple bond, we have alkynes. Like ethyne, this is C2H2. It is also called acetylene, which is used for welding, oxyacetylene flame. Now, in this ethyne, and then there is propyne, and then there is butyne. So, what will be the general formula? CnH2n minus 2. We all have names, plants and animals are also given names. Why do we like to name? Is it just a fancy? No, there is a method behind it. By name, it is easy to recognize, it is easy to relate. So, that world over scientists can understand some names are given, but this system of naming has to have a system. So, the system of naming is called nomenclature. Whenever we want to name an element, there are some steps in it. The first step is identify the number of carbon atoms. For example, in methane there is only one carbon atom. Second is identify the functional group. Whether it is a halogen or it is an alcohol, aldehyde and so on. Third step is that what we do in the case of functional group is that we have certain suffixes and the prefixes. What is a prefix? Prefix is a word before. Like say Kumari Pratima. So, Kumari is a prefix and then there is a suffix like our surname, for example Kamlesh Verma. So, Verma is the suffix, a word after. If it is a halogen, we start with the prefix chloromethane, and if it is a functional group other than halogens, then we use it as a suffix, and for that also there is a method. For example, what we do is we delete the last E or the last few letters. For example, for alcohol, what we use is OL. So, the word from methane, this E will be removed and OL will be attached. So, it will become methanol. From ethane, E will be removed, OL will be added, it will become ethanol. That is methyl alcohol and ethyl alcohol. Fine. So, for alcohol what we are using is OL. For aldehyde we add the word Al. For ketone we add ONE. So, if we take the case of propane, it will become, E will be cut and it will become propapanone. Propanone. In the case of carboxylic acid, what we add is OIC, oic. So, propane will become propoic acid, ethanoic acid. So, this is how we name. I am repeating, count the number of carbon atoms, then see what is the functional group, then use as prefix or suffix as given. You can't do this that you choose your own. What will happen if you give your own name, then say countries other than India, the scientists there will not understand. So, we have to have a universal language, a common language. That is why the symbols, the formulae and the equations are written like this, because they are understood all over the world.